Hi, everyone. Thank you for joining this session. Couple of reminders. Please make sure you fill out the survey at the end of this session in the app. If you do so, you will redeem a free AWS swag item at the info counter. And also, if you would like the slides directly after the session, you can scan your badge right here at the front at the end of it. And at this time, I would like to announce Dennis Magsajo presenting on implementing a data warehouse on AWS.
All right. Hello. Oh, thank you. So good afternoon. I hope you guys are enjoying the summit so far. Are you? Are you? Right. So how are things? Is it too cold? I feel that the room is a bit cold though. It is, right? Yeah, so I noticed that. So feedback, right? There's a very interesting distribution in terms of seats. So I'm not sure if the guys on this side are just, related or close to each other. But if you look at on that side, it's almost, you know, like you can practically lie down across three seats, right? So this is a very interesting distribution. Yeah. So today we're going through data warehousing in a hybrid environment. So this is a very interesting topic because more often than not, when I go to customers, I present hybrid or I present data warehousing, right? So even my previous life prior to AWS, I used to do that. So I worked for a large database company, and data warehousing is one of the things that I usually present, right? But in this case, we are trying to merge two concepts together, hybrid and data warehousing. And in fact, you would eventually realize that given the momentum of cloud, there would be a lot of customers who would be looking into this, right? So it's like a mix if you know DevOps, right? Data warehouse and hybrid is like the data center providers mixing with those doing analytics and business intelligence, right? So I'll be going through a couple of things. Well, typically, why you would want to do hybrid, and also AWS's implementation of a data warehouse, and we'll be going through a couple of design considerations and at the same time maybe a use case. So at least you would know how other customers are implementing data warehouse in AWS in a hybrid fashion, right? So let's get to it. A hybrid cloud environment. Why would you, in fact, go hybrid? So these are a couple of reasons. One, let's try to put this in a data warehousing perspective. You would want to run workload on premises because probably if you have done data warehousing before, data warehousing without the sources will not provide you anything, right? So chances are, if you have a data warehouse, you have at least one or two or even more sources. But if you're starting to venture into cloud, it now becomes a question, okay, I have all of these systems, including my data warehouse on premises. Do I need to move everything into the cloud for me to perform data warehousing in AWS, right? So those are just the questions or restrictions that you would get, but at the same time, so you tend to keep most of the mission critical on-prem at first rather than putting everything in the cloud. But you would want to leverage the scalability, the performance of cloud. Hence, the second one is running workloads on the cloud. But once you do that, now suddenly you're thinking, okay, I have different systems running in different places. There has to be some form of tight integration, right? So that has to be something that I would require if I'm going to implement data warehousing in a hybrid fashion. And lastly, I'm trying to avoid to buy new hardware, right? So for those of you who have ventured or who have tried shopping different data warehousing providers, you would know that it's not cheap. Usually these are machines or appliances or physical servers that are high spec, lots of memory, lots of storage. And it's not just that. If you're going to buy that, chances are you would need a sophisticated data center to maintain the cooling, etc., etc. So it would be a series of investments that you would have to do, right? But if you're thinking, no, but I would want to reduce on costs. Hence the fourth item in the slide. Okay. So going to the other side of things, data, right? So maybe for those who have been in IT for a couple of years, you know that data is not a linear function. The growth, I mean, is not linear. It will always be exponential. In simple terms, just think of how big a thumb drive was 5 years ago comparing to thumb drives today. I've seen like 1 terabyte, 2 terabyte thumb drives, right? When I started off, if you have a 2 meg thumb drive, you'd be really happy. Wow, that's a lot of text files, right? So the rate at which data would be going in would be very much exponential. So there's more data than people think. The only reason that you do not see it is we do not have the capacity or the capability to store things, right? So you might be thinking, okay, can I do a historical report? Let's say 100 years ago, what was my data? Well, we don't have that. When you said, okay, then why? Because we don't have any place to store it. But now as technology comes in, you now have the capability to store data. But then again, once you have it stored, what do you do with it? Right? Suddenly, my 4 cores, my 16 cores of processing my report is no longer enough because I have a lot of data. Okay? So it's hard to discuss data warehousing without going through the whole analytics pipeline. Right? That should always be the case. So if just an advice, if you're looking into data warehousing, look into things around your data warehouse. What do you intend to do? What are your sources? How long do I have? Right? So what formats do I have? So like, for example, collection. Right? So are you coming from a relational database? Is one of my sources relational database? Is my data greater than 6 terabytes? So maybe I would need something like AWS Snowball to bring those larger data sets into the cloud. Things like Kinesis, if you're looking into streaming data, so that's turning out to be really popular, especially in the age of social media, click streams, IoT. Because suddenly, well, a couple of years back, my problem before was it's like what we call an N-1 report, meaning it's a report I run about yesterday's data, right? But now we're going into real-time data analytics, where it's critical to know at this particular second, how is my business performing, right? So you now have data sources that would be able to provide data on a per second or sub-millisecond basis. And of course, as I've mentioned, you need a place to store that, right? So it's not just a simple hard disk. There are different ways of doing that, right? So again, going back a couple of years, when people think data warehouse, it's relational by nature. You have a main table, you have a fact table, you have dimension tables, you have star schemas, and then you run queries using joins, right? But how would you do that if you're trying to run a report on comments in, let's say, Twitter, social media, right? Or devices, right? So if those of you wearing activity trackers, they would be sending a lot of small data, a lot of them, but it's really simple. It's just one line, probably 3 columns, but you have to run a report on. It's not relational, right? So hence, there has to be a means, instead of trying to cram all those different structures into a single database, you should be able to have options. So in this case, if you want a relational data store, we have that. If you want it NoSQL, for example. If you want it unstructured, there's S3 or the simple storage service. So we do offer a lot. So our stand with regards to storing data is purpose-built databases, right? So again, I know because I have worked with a large database company before, where we try to put in as many features into a single database, right? Like immutable ledgers, non-structured videos, images, etc. But once you start doing that, and a customer asks, "Can you provide me with a database?" Yeah, I can give you this one database, does everything. But customer says, "But I only need one portion of that, and you're asking me to pay for the whole thing." Right? So that's why we're very much a believer with regards to purpose-built databases. And of course, you collect, you store, you would analyze, right? Again, we would give you a list of services depending on what analytics you're looking into, right? If you're looking into transformation, we have a managed ETL service in the form of AWS Glue. If you want the sort of traditional data warehousing functionality, then we have Amazon Redshift, which I'll be digging deeper in a while. But at the same time, things like Hadoop, EMR, analytics, Elasticsearch, etc. So again, we will be providing a lot of services for you to run your analytics on. Okay, and of course, at the end of it, you should be able to perform a lot of things. Let's say you've already transformed all your data. It would be nice if I can show it in a graph, for example. So we do provide services for visualization as well. And at the same time, from the data that you've collected and transformed, you should be able to run, in this case, like machine learning, right? So a lot of customers are very much interested in machine learning now. Why? Because I'm no longer satisfied with getting, let's say, what was my sales in the last 6 months, right? They are now looking forward, prediction, right? So what will happen if I introduce a new product? So those are the questions that are coming out. So not like the quantitative things like how much, how many, right? So now you're looking into questions that are in a higher level, but given the data you have, it shouldn't be that much of a problem if you'll be going to machine learning, right? So we'll be like drilling down. So we went through the analytics pipeline, we went through the workflow, and then we're going through the data warehouse itself. So emphasizing on the data warehousing service. So we need to sort of modernize. I mean, data warehousing is not a new concept. Everyone's been would have been familiar if you've been in IT. So, but there are a lot of improvements that customers desire, like scaling of data, right? So you can't say that we can only run this report because you only have 1 terabyte of storage, right? So the objective of the data warehouse is if I have a question, right? So those shouldn't be limiting factors if I would want a business question answered, right? And of course, it has to be fast, not just fast for one user, but if I have multiple users, then it should scale the performance as well, right? So gone are the days where you have a single group or a single person where you ask your report, can you give me a report about history? Okay, then the analyst will run the data warehouse, right? So now customers are starting to open the data warehouse platform such that a lot of users should be able to handle them concurrently, right? So if we are in the dawn of web services where I can run a query on your website, on a customer website, and it should run a query on the data warehouse and give me the results, right? So just imagine in a scale of, let's say, students or doctors or citizens that are trying to access your data warehouse. So it becomes important that performance should be able to scale as well. And given all those features, it should still be, it's desirable that it's easy to use. I wouldn't want that, I want to run a report, okay, then you go to the specialist, go to the, and tell them to operate this machine, etc., etc. So it has to be easy to use for the business users. I don't have to like talk to a lot of people just to get my report. So we try to make it as easy as possible. And after data warehouse came the concept of data lakes, right? So I've mentioned to you, okay, a lot of the data warehouse before were relational in nature, meaning structured, but with the data that we're getting right now, a lot of them, in fact, are unstructured. Social media, text, videos, images, right? So there has to be a means, so try to imagine inserting an MPEG or a JPEG into a relational table. That wouldn't work, right? So you can try to force it with large objects, but it will not work. So data lake came into play, right? But then again, okay, I have a data warehouse and I have a data lake, but I want to correlate. I want to know the relationship of the data that I have. It can be a financial system versus, let's say, tweets regarding my company, right? So this should be able, the platform or the service should be able to give you the capability to correlate your data warehouse with your data lake, structured with unstructured, okay? So the data warehouse in AWS, there are a couple of design considerations, right? But if you would look at them, which I'm sure you're looking now, this is not much different from how you would normally evaluate or design your data warehouse, right? So you want to know, is it batch or real time? Data quality, it's always been there. You would want to look into auditing, nightly jobs, ETL. And again, these are things that you would normally do in a data warehouse. The difference is the options that you have or the tools that you have when doing or trying to satisfy those requirements. Starting from collection until visualization, we do have a lot of services. So let's say you have multiple sources. I have a Postgre or an Oracle database or MySQL database running on-prem. Use DMS. DMS takes it, extracts it, puts it in Amazon S3 or the simple storage service. But I also would want to have like files, text, logs that I would want to run analytics on. Then you can use DataSync or Snowball, depending on the size. That will then will get extracted and then loaded and put in S3 again. And once everything in S3, you can run services like EMR or Elastic MapReduce to do further transformations and then bringing it back to S3. S3, by the way, or the simple storage service, is one of my favorite services. It's like a Swiss Army tool of functionality. So you would see that in a lot of our architecture. But anyway, so Glue, our managed ETL service, should be able to properly orchestrate the transformations that you're doing and eventually putting it into Redshift. Now, after Redshift, you pick your BI tool. And having said that, looking at this architecture, it does not have to be this complete set. I have had customers who say that, okay, I'm more comfortable with this other BI tool. Will that work? Yes, it will work. So we do not tie you up or lock you in any of our services. So we embrace open source. So like, for example, we have a database we call Amazon Aurora. This is something, this is a MySQL or PostgreSQL drop-in or flavor, which preserves the functionality of those open source database engines, but we tweaked it to be cloud native, right? So we do not lock you in. Now, again, another level deeper, so going to the service itself. So there are a lot of things that this, remember the requirements I've mentioned earlier. So Redshift ticks all the boxes. It can be fast, it can scale in an unlimited manner, and it can extend your data lake, but at the same time, it's 1/10 the cost. You might be thinking, 1/10 the cost, are you sure? Right? Because remember, a lot of the traditional data warehousing engines or solutions, they usually have licenses. But remember, we're now switching to open source, so a big portion of that is license costs, MAs, or maintenance agreements or annual recurring charges, right? Okay? So, but in a nutshell, or if you want to simplify the why Redshift is something to consider, it's because of its speed, it's simple, it can scale, and it's highly secure. All of our services are highly secure, but we would want to emphasize that Redshift, being one of the AWS services, is also highly secure. So in a more technical architecture, if you would look at this, so you have a leader node, right? And then you have like compute nodes. So what will happen is if there's a request, it's sent to the leader node, and the leader node will be distributing the query across the different nodes, right? So I have a very interesting analogy later, but basically the leader node is the orchestrator, the compute nodes does the computing, right? Hence compute nodes. And you have two hardware platforms, so you can choose whether you would want to stick with HDD or hard disk drive spinning disks, or there's an option for SSD if the latency is important to you, okay? So looking deeper into the compute node, it's a machine that you can chop or slice or partition, however you would want to call it, into smaller slices, and then those slices are then used to process the requests, right? So it's SMP. So for those who have been working with large hardware providers, SMP or symmetric multiprocessing, it's the same concept. Highly parallelized, right? So as I mentioned earlier, security will always be built in. So something that I would want to highlight is Redshift is a managed data warehousing platform. So that means all the compliance certifications, attestations that we have in AWS applies to Redshift. So you would see PCI DSS, FedRAMP, etc. Right. So some of them, there are country specific that you may want to look into as well. We have a website for that one, so you can check whether you're coming from Malaysia, Philippines, Singapore, etc. Right. So that's on the compliance. Everything is encrypted end to end, and there are keys with the AWS KMS or Key Management Service. And there's network isolation. So if you would look at the diagram, um, the network of the leader node is different from the network of the compute nodes. So you have access to the leader node, but the compute nodes are internal. Okay? So some design considerations, right? So again, this still applies to other data warehouse platforms, but basically if you're looking into small data sets, so you might also, then small is relative, right? So if your data set is less than 100 gigs, then chances are you won't get much benefit from Amazon Redshift, right? The fact that we've split it into leader nodes, compute nodes, it introduces some degree of overhead that you can only will only break even, maybe around 100 gigs worth of data, right? But the larger it is, the better we scale, the more performance that you'll be getting. OLTP would also be challenging, especially if you would think about the notion of breaking up into smaller pieces. It would be problematic for OLTP systems to run on top of it. And again, if you're looking to store unstructured data, Redshift probably is not the right service to use. So with that, you may want to look into DynamoDB or other databases that are meant for unstructured data. S3 would be one of them. And of course, for blob store as well, so as I've mentioned, images or large objects, they are better off not residing in Redshift. Okay? So data design, so this is very important as well. So you need to pick the right data types. My rule of thumb, if you have a file, a flat file, JSON file, YAML, Parquet, Avro, ORC, from readability to going binary, performance is usually faster going binary, right? So JSON, YAML, they're built so that it's human readable, but the performance goes down because we made it human readable. But if it's machine readable, then the performance is a lot better. So opt for Parquet, Avro, or ORC. And of course, you need to properly load and distribute. As I've mentioned, this is a very interesting analogy. If you're going to load your data, there are a couple of ways you can do that with Redshift. So just looking at this one, we have 9 columns, right? So this is what you call unbalanced distribution, right? So chances are those guys there are comfortable with the air temperature, and those guys there are freezing right now, right? So it's in the same case when you're distributing your data. If you want it optimally performant, you have to properly distribute. So 3 ways. You can do round robin, meaning if one of you comes in, you sit here, you sit here, you sit here, you sit here, you sit here. So it becomes even, right? The second way, which is good, because if you're going to read data all at the same time, then you're utilizing all nodes. The second is, what if I want to do joins, a master table and a child table? Then you have an option to store it by key, distribution by key. So that sort of algorithm or scheme would store the row per key, meaning if my master record is here, my child record here is here as well. So I don't have to scan everything if I just want, let's say, a master record and a child record, right? So it takes away the latency if you're trying to fetch it from different places. And the last one is all, where you have a copy, the full copy in each node. So that's going to be, well, storage-wise a little more, well, significantly more than the other schemes, but it's going to be highly performant and highly available as well. But you have that option. It's up to you how you would want to configure it. Okay? So some features that I would want to highlight: dense compute nodes from DC1 to DC2. Maybe for those who have been doing AWS for some time now, the last number is generation of the instances that we offer, and we offer 2 times the performance of DC1. Again, in terms of continuous improvement in innovation, we try to bring in and put customers the most recent versions of technology so that they get the full benefits of newer technology. There's also result set caching. So, well, as the name implies, if you perform a query, you got a result. If you want to run the query again, doesn't have to read everything else because the results have already been cached. Some other considerations: let's say I'm a power user, I run a 3-hour query, but at the same time I have, like, I did real-time analytics and I opened it to other users as well, but they will only be doing short queries. So instead of them waiting for me to finish, right, they can go in and, well, not really preempt, but they can execute outside of the space of the long query, right? Elastic resize, this is very interesting because this would be useful especially if you're not sure how much resource your data warehouse would use, right? So with elastic resize, what it does, as the name implies, if you need more power, you get more nodes, right? And the nodes that you use, you only pay for the nodes that you use, right? So it's auto-scaling in a warehousing perspective, right? Now there's a different approach to that, which what we call is concurrency scaling. This only works for queries or reads, by the way. So what it does, it spins up separate clusters to do the queries outside of your main cluster. So it complements or supplements the performance by bursting additional clusters to do the queries, right? And if you would want to correlate your data warehouse relational to, let's say, something in S3, which is unstructured, we have what we call Redshift Spectrum, where if your file is in Parquet or Avro, without having to load those files into Redshift, when you run the query, you should be able to read the data that's still in S3. Right, so that's a very interesting feature. One, it saves you a lot of space. You have the unlimited space in S3 and the durability as well, but at the same time, without having to do massive ETL of S3 into Redshift, you are able to perform the queries, right? And you can mix and match. I can join a table that's in my Redshift cluster to a table, an external table, that maps to an S3 bucket, for example, right? And I can run my queries as usual, right? So the new features, well, in a nutshell, we do have a lot of them, and we do have a couple of them coming out as well. So you will have a copy of the slides. So I mentioned about short query acceleration, data distributions, elastic resize. There are a lot of improvements that we will be introducing in Redshift. Right, so I have a couple of minutes to go through a use case. So one of our customers, Fannie Mae, implemented or used Redshift for data warehouse. So just to give you an example, they provide loans, right? So in this case, home financed by Fannie Mae Storage Express. This is a U.S. company, by the way, right? But that's the profile of their business. So their data warehouse, well, it's system records. But what's interesting is they would want to consolidate legacy data warehouses. So you've heard of data warehouses and data marts, right? Where each department, maybe in a company, would have different data marts, or even they have their own data warehouse. Then someone came up with the term enterprise data warehouse, which is supposed to like supersede everything. So I don't know if next year will be mega super data enterprise warehouse. I don't know. But the fact is, you still have silo data warehouses, right? One, maybe budget. Second, capacity, right, etc. Different reasons. So challenges, they would want to consolidate. And they're getting 6 to 20 times transactions in the last 18 months. They want to digitally transform. So it's short of saying, they need to scale, they need to do it fast, and they need to serve the business. Okay, so what they needed was self-service. It should be able to dynamically scale. It should be able to data share, because as I've mentioned, they tried to consolidate different domains, cross domains, right? in Redshift. So there has to be a capability to be able to share that, and at the same time, high concurrency, because now you've pooled all the users from the different domains into Redshift, right? So solutions that we offered, of course, as I've mentioned, they did Amazon Redshift Spectrum if they're looking at different sources outside of relational. So they use that. And then they use concurrency scaling to improve performance and concurrency. I'll be showing you a couple of numbers to show the results that they got. Um, some administration automation to make things a lot easier. Because remember, you have consolidated multiple domains, and there's a certain amount of work that has to be done to maintain it. So we've introduced, or there are functionalities that would make it easier. I would want to highlight the part of AWS portion. Earlier, I've mentioned that if you're going to evaluate a data warehouse platform, yes, it's good to know if it's highly performance, highly durable, etc., specific to the warehouse. But again, you throw the question, what am I going to run on top of this data warehouse? That's where the other AWS services come into play. You want to run machine learning? We have SageMaker. You have Amazon Machine Learning. You want to attach it to IoT? We have Amazon IoT. If you want mobile device access, we have the Mobile Hub, right? Suddenly, of course, you've heard of Lego bricks, right? So we have always been using the term Lego bricks for AWS services. You now have a huge set of possibilities that you can use to complement and or supplement your data warehousing solution. So it's not enough to say, my data warehouse is fast. The boss will say, okay, it's fast, but can it answer my question right now? So those are the things that needs to be considered. So in their case, they were able to move from the on-premises and make it hybrid in the sense that the sources remain on-premises, but they're able to extract. As I've mentioned, S3 is an excellent service, my favorite service. So you can put anything in there, and once it's in there, you can pretty much run any AWS service on top of it, including Redshift. Okay, concurrency scaling. They've compared 16 nodes versus 8 nodes with concurrency scaling. And looking at the graph, it's equal or even better like query 3. That's more than half performance gains. Right? Hence, you're doing more with less. Right? So that's something that's good to highlight. And of course, when you increase the level of concurrency, you can see with concurrency scaling feature, it maintains, right? So it's sort of flat, the performance or the time, the execution time for the queries that are being thrown at it. Okay? Lessons learned from Fannie Mae. Choose the class type wisely. That you then might be like, okay, Dennis, so what's the right class? That's the beauty with cloud, right? If you pick and you pick wrong, it's so easy to recover from failure. Use DC2. If it doesn't work, use the other one, right? So it's as quick as switching the clusters, unlike, okay, I bought a data warehouse. Oops, we bought the wrong size. Can we return it? Right, so that's the benefits that you get if you move to the cloud platform. Concurrency scaling feature only works for read-only queries. So that's something. So you don't expect that if you have concurrency scaling and then you're loading data, that will not work. It only works for queries. There's an overhead of activating the concurrency scaling, right? So that means there's a 60 seconds overhead. If your query runs for 30 seconds, do not introduce concurrency scaling, right? Because even if you improve it into 1 second, that's 60 plus 1, that's 61 seconds versus the previous 30 seconds, right? More nodes do not always yield better performance. This has to do with utilization as well. The fact that the 8 nodes perform better is because there are a lot of bursts into the workload, right? So it does not improve the performance, but in this case, you can split it into read versus those that's loading. Then it can be done with less nodes. Of course, cost would always be a consideration. Measure performance with cost, right? So I'm a gearhead. I like new things. I like fast things. I like shiny things, right? But once you go to the customers, that will not always be the case, especially if you're talking to those like the CFO, those doing the budget, right? Yes, that's good. It's faster by 15 minutes, but do we need the 15 minutes? If you're given an hour to run a report and you ran it in 45 minutes, if you ran it in 30 minutes, will it have any impact on the business at all? Yes, it would, because you spend more hardware into it or processing power, but the results are still the same. So you have to balance out the performance and the cost. So that's going into functional and non-functional requirements. Right? So I guess that's it for my presentation, and thank you, and I hope it was useful to you. To give you an introduction, it was a very short presentation. In fact, it's like 35 minutes, right? But that's a lot of, I know that's a lot of info to digest, but I hope it was useful. Thank you.
Thank you, Dennis. And I'd like to remind everyone again to complete the survey in the app. And if you do so, you can redeem an AWS branded item at the info desk. And again, if you would like the slides right after the session, you can scan your badges right over here with the content team. And the next session will be Cloud Data Management with Veeam and AWS starting at 2:30.